On number 1, our goal is to write in the top row 16 to some power, and then in the bottom row rewrite each of these as either radicals or rational numbers. So for the first one here, 16 to the first power, well, I'm just simplifying that. Anything to the first power is just itself. Here then, we need to think how to rewrite a fractional power using radicals. The denominator of the fractional power becomes the root. So since that's a 2, this would be a square root. And then the numerator of the exponent stays as a power. So this would just be the square root of 16 to the third. Here, in this one, I need to figure out 16 to what power equals 4. Well, I recognize that the square root of 16 is equal to 4. And if you remember, we talked about the 1/2 power is the same thing as a square root. 16 to the 0 power, well, anything to the 0 power is just equal to 1. 1 over 16, well, this is where we get into negative exponents. So here, 1 over 16 is actually 16 to the negative first power. Remember, negative exponents, if I've got anything to a negative power, like 16 to the negative fifth power, that is just 1 over 16 to the positive fifth power, right? So that would apply here as well. If I've got 16 to the negative second, that would just be 1 over 16 to the second power. On number 2, we want to get into solving quadratics. Now, we have different methods that we talked about. The two big methods were either completing the square or quadratic formula. Those are the two that always work. But we did have different criteria for those. Now, we do generally want to check to see if these factor first. Factoring is always the easiest method. So remember, it's worth it to check. So set up your x factor, multiply a times c, so 1 times -3 up top, and then b in the bottom. So are there two numbers that multiply to -3 and add to 10? No, there are not. So we can move into either factoring or quadratic formula. So the criteria, or I'm sorry, not factoring, completing the square or quadratic formula. So the criteria for completing the square is my a value 1 and my b value even? In this case, yes, it is. So completing the square is probably going to be the easiest method. To complete the square, remember we need our x squared and our x term on one side and our constant term on the other side of the equation. So I will start by moving that 3 over. So then I'll have x squared plus 10x, and this is where we put in that plus blank on each side, because I know I'm going to have to add something here to complete the square. That something is always b divided by 2 squared. So my b value here is 10. 10 divided by 2 is 5, and 5 squared is 25. So this value will be 25. And again, I'll write this down. This value is always b divided by 2 squared. So now, on the right side, I can just do this arithmetic. 3 plus 25 is 28. And on the left side, what we've created is a perfect square trinomial. This will factor into a binomial squared. So I could set up my x and go through the process of x factoring, but the shortcut, since we have created this perfect square trinomial, this will always factor into x and then whatever half of b is. In this case, b is positive 10, so this will factor into x plus 5 squared. Now, from here to solve, right, to solve this, I can take the square root of both sides. So the square and the square root cancel out on the left, and I just get x plus 5. On the right, don't forget that whenever we take a square root as part of the solving process, we will have plus or minus the square root of 28. Now, 28 is not a perfect square, so I can just leave that as the square root of 28. And then I have one more step to get x by itself, subtract the 5 over, And we can write our final answer as -5 plus or minus the square root of 28. Now, again, remember, if I wanted to show my two separate answers here, my two answers would be -5 plus the square root of 28 and -5 minus the square root of 28. Those would be my two answers. But it's perfectly acceptable to write our two answers like this. Same thing on the next one. We just want to solve this quadratic. So again, it's worth it to set up our x factor to see if this factors. So a times c, 3 times -8 would be -24, and then my b value is -4. So are there two numbers that multiply to -24 and add to -24, or add to -4? I don't think that there are. Right? So again, in this case, I cannot factor. So we need to choose either completing the square or quadratic formula. For completing the square, remember our a value has to be 1. In this case, our a is not 1. So quadratic formula is probably going to be our best bet here. Now, remember, quadratic formula always works. So even on the last problem, we could have used quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, my a value is 3, my b value is -4, and my c value is -8. So I'm just plugging those values in. So the opposite of b, the opposite of -4, would be +4 plus or minus the square root of, my b is -4, so -4 squared minus 4 times a times c, and all of that over 2 times my a value of 3. And then we just want to simplify from here. So I'll start with my values under the square root. So first, I've got -4 to the second power. Remember, that will be a positive 16. Don't get tricked by the calculator, right? If we do just want to plug this into the calculator, make sure that you are using parentheses around negative values like that. Okay, so then minus 4 times 3 times -8. So -4 times 3 times -8 gets me 96, a positive 96, because we have a double negative. So plus 96 all over 2 times 3 is 6. Inside the square root then, 16 plus 96 gets me 112. And 112 is not a perfect square, so I can't simplify that square root any further. But we do still, at this step, let me finish this out up here, we do still want to split this fraction up like this, okay? Because even though 112 is not a perfect square, so I cannot simplify this fraction, I do want to check to see if I can simplify or reduce this first fraction. 4 over 6 does reduce. That will reduce to 2/3. So I can express my final answer as 2/3 plus or minus the square root of 112 over 6. On the next one, again, check to see if it factors. So a times c, 1 times 13 is 13. My b is -4. So two numbers that multiply to 13 add to -4. Once again, I don't think there are any. So this one does not factor either. So this one would be a good candidate for completing the square because a is 1 and b is even. So I'll start by moving my constant to the other side. So we will have x squared minus 4x, and I'll put in my plus blank equals -13 plus blank. Now that plus blank will be b over 2 squared. So my b value is -4. -4 divided by 2 is -2, and -2 squared would be +4. So I would add 4 to both sides of my equation. On the right side, -13 plus 4 will be -9. And on the left side, x squared minus 4x plus 4. We've created a perfect square trinomial that will factor into a binomial squared. And the shortcut is this value will always be b over 2. So b is negative 4. Half of that is negative 2. So x squared minus 4x plus 4 will factor into x minus 2 squared. From here, take the square root of both sides. So the square and square root cancel out on the left side. I just get x minus 2. On the right side, I need to simplify the square root of negative 9. So first of all, plus or minus when we take a square root. And now, whenever we had a negative inside of the square root, remember we split this up into two different pieces. Okay, we said we could write the square root of our value times the square root of negative 1. And the reason that we did that is because we know that the square root of negative 1 is equal to I. So here, 9, or the square root of 9, that is a perfect value, right? The square root of 9 is 3, and then the square root of negative 1 is I. So we can say the square root of negative 9 is plus or minus 3i. One last step to get x by itself, add the 2 over, and we can say our final answer is x equals 2 plus or minus 3i. Don't forget, whenever we have a negative inside of a radical, basically that just comes out as an I. On the next one, we are solving some equations with radicals and different powers. So the first thing we want to do is isolate the square root in this case. So I need to add the 9 over to the other side first. So I will have the square root of 4x plus 3 equals 7. Now I need to undo the square root. So to undo the square root, I will square both sides. On the left side, the square and the square root undo each other, and I just get 4x plus 3. On the right side, 7 squared is 49. And now we just have a two-step equation to get x by itself. Start by subtracting the 3 over, so 4x equals 46. Divide both sides by 4, and 46 divided by 4, I believe, gets us 11.5. On the next one, similar idea, I need to isolate whatever is being raised to the power. So I will start by subtracting 9 over. So we'll get x plus 5 to the third power equals 8. And now to undo a cube, we will cube root both sides. So the cube and cube root cancel out over here. We just get x plus 5. And on the right side, we would have the cubed root of 8. Now that is a perfect value. The cubed root of 8 is just equal to 2. Now remember, whenever we are taking a cube root, this is not plus or minus. That's only when we are taking an even root, like a square root, a fourth root, and so on. So I just have one last step to get x by itself, subtract the 5 over, and we get negative 3. On the next one, we are adding these two complex numbers together, and we have this result. We just need to fill in the blanks. So remember, when we are adding complex numbers, we're essentially just combining like terms. We're adding the real parts together, and then separately adding the imaginary parts together. So here, this first part is basically saying what plus 7 equals negative 11, right? Well, I can think about this as a variable, right? So just subtract the 7 over, and I would get negative 18. So if I plug that in here, negative 18 plus 7 is in fact negative 11. I can do the same thing here, right? If I'm just looking at the imaginary parts, I'm essentially saying negative 9i plus what equals 5i. Well, again, I can think about this as an equation. I can add the 9i over to get the blank by itself, and that would give me that this has to be 14i. On the next one, we are actually performing some operations on complex numbers. So for this first one, just like the last problem, all we're doing when we are adding complex numbers is combining like terms. So 2 plus negative 5 is negative 3, and 3i plus negative 7i would be negative 4i. On part B, same thing, except this time we are subtracting. So I do like to do a little intermediate step here and essentially distribute this negative sign through the parentheses. So I'm just going to rewrite this as negative 4 plus 2i minus 5 plus 8i, right? Because I have the double negative here. So now if I combine my like terms, negative 4 and negative 5 is negative 9, and 2i plus 8i would be 10i. On the next one, we are multiplying these complex numbers, okay? This is where we either have to double distribute, or the way that we practiced doing this in class was with a box. So if I set this up as 5 minus 6i times negative 2 plus 3i, I'm going to get 4 terms here. So negative 2 times 5 is negative 10. Negative 2 times negative 6i would be positive 12i. 3i times 5i would be 15i. And then 3i times negative 6i, well, that would be negative 18. And then I times I would be I to the second power. Now here, we need to simplify this term because we have talked about the idea that I to the second power is equal to negative 1. So this just becomes negative 18 times negative 1, which would be positive 18. Now, amongst these 4 terms, I can combine like terms. So for the real part, I have negative 10 and positive 18. Those would add up to 8 when I combine them, and then 15i and 12i would combine to 27i, right? Once I have all 4 of these terms, I'm just combining the like terms. And we had to simplify using the fact that I squared was equal to negative 1. On the next one, we are just trying to write a function to model this situation. So our initial population in this case is 8,000. And after 3 days, the population tripled. So to write a function to model this situation, right, we're saying f of d equals, well, we always start with our initial value times our growth factor. So this is our growth factor, right? It says we are tripling. But that's our growth factor over a 3-day period. So to show the growth factor over a 1-day period, I would need to raise this to the 1/3 power. But if I want to throw in a variable where d represents any number of days, I can raise that to the d over 3 power. On number 7, we have a half-life problem, right? So our initial value is 3.2 milligrams. Half-life tells me my growth factor. My growth factor is 1/2, but that's over an 8-year period. So similar to the last problem, right, I can write my function as initial value of 3.2 times my growth factor of 1/2. But that, again, since that's over an 8-year period, I will raise that to the t over 8 power. So then to figure out how much is left after 8 years, 4 years, 1 year, all I'm doing is plugging these values in for t in my function. So 3.2 times 1/2 to the 8 over 8 power, 3.2 times 1/2 to the 4 over 8 power, and 3.2 times 1/2 to the 1 over 8 power. And I can just plug each of those into my calculator, right? So 3.2 times 1/2 to the 8 over 8 power. And then just do that again to the 4 over 8 power, and do that again to the 1 over 8 power. So these would be my 3 values. On number 8, we are solving these exponential equations. So whenever we are solving an exponential, I need to get the exponential part by itself first. So in this case, I need to divide by 5. So the 5's cancel out over here. We just get 10 to the n equals 100. Once I get the exponential by itself, I want to rewrite this as a log. So this will become log base 10. Whatever the base of the exponential is becomes the base of the log. So log base 10 of 100 equals my exponent of n. And then we could put this in the calculator because my variable is by itself. So remember, this button here is already log base 10, so I can just do log base 10 of 100, and that's just equal to 2. Right? This one, I mean, we probably could have figured that out at this step, right? We could have figured out that n was equal to 2. On the next one, same process. Start by getting the exponential by itself, so I need to divide both sides by 4. So we get 10 to the 2y equals 900. Now I can rewrite this as a log. So log base 10 of 900 equals my exponent of 2y. I still have one more step in this case to get y by itself. I still need to divide both sides by 2. So I can now put this in the calculator. Log base 10 of 900 divided by 2. And I will get 1.4771 if I round to 4 decimal places. On the next one, same process. Start by dividing both sides by that coefficient of 7. 56 divided by 7 is 8, and at this step I can rewrite this as a log. So this would become log base e, or we know log base e is the natural log. So natural log of 8 equals my exponent of x plus 4. To get x by itself, I still need to subtract the 4 over. So I will end up with natural log of 8 minus 4 equals x. And I can put that into my calculator then. So natural log of 8, close my parentheses, and then minus 4. So negative 1.9206. If I round to 4 decimal places, this one would get bumped up to a 6. What was it? Negative 1.9206. 9206. All right, on the next one, we are given logs, and we need to rewrite each of them in exponential form. So for this first one, I don't see a base. Whenever we don't see a base, remember that is base 10. So to rewrite a log in exponential form, the base of the log is the same as the base of the exponential, and then whatever the log is equal to is the exponent. So this would be 10 to the x power equals 100,000. Now, we could just put this in the calculator, log base 10 of 100,000, but if we think about it this way, 10 to what power is 100,000? Well, we've talked about essentially if I'm raising 10 to a power, I just need to count the zeros, right? So 10 to the 5th power is 100,000. On this one, if I want to rewrite this in exponential form, remember when I have the natural log, that's the same thing as log base e of x equals 5. So here, if I rewrite this, the base of the log is e, so that'll be the base of the exponential. This would become e to the 5th power equals x. And again, I can put that in my calculator if I want to get a decimal. Remember, e is second division, so e to the 5th power. So 148.4132. The next one, again, same idea as the first one. To rewrite in exponential form, this would just be 3 to the x power equals 729. So we're trying to figure out 3 to what power equals 729? Well, we can just plug log base 3 of 729 into the calculator. So remember, that is under the math menu, and we can just scroll up to log base, or I can just do math alpha math, and that gets me log base. So log base 3 of 729. So that tells me that 3 to the 6th power is 729. On the next one, we are just trying to figure out how to transform this solid curve to this set of data. So I want to write a transformation of P that best matches this set of data. So I need to figure out how far left or right and how far up or down I need to translate. To do that, I can just pick out, one specific value and see how far I'm going, right? So, we can look at any point, but if I look at maybe this local max here, it looks like I'm going to that corresponding point up here. It looks like I'm going right 1, 2, and then up 1, 2, 3. So I could say, they don't tell us what our new function is, but I can just say, if I'm going right 2, then I would express that as P of x minus 2. And then if I'm going up 3, I would have plus 3. So right 2, up 3 will look like that. For 11 and 12, we are just describing in words what the transformations are, right? So there are 3 things that are happening on this graph. If first I have a negative sign on my x, right? If I'm taking the opposite of x, that is a reflection across the y-axis. If I'm taking the opposite of x, that is a reflection across the y-axis. Then a plus 4 on the inside of my function, that would be left 4. And then a plus 2 on the outside would be up 2. Same idea on number 12, right? So a negative sign on the outside in this case, I'm taking the opposite of y, so that would be a reflection across the x-axis. This minus 3 on the inside, that would mean right 3, and then minus 8 on the outside would be down 8. And on my last one here, we are given the description of our transformation in words, and I need to write the function, right? So the graph of f of x is transformed to create g of x. That means that when I'm writing this, I should have g of x equals f of something, right? So first of all, a reflection across the y-axis. Well, that means I need the opposite of x. So inside of my function here, I will have negative x. And then if I am going left 8, that will be a plus 8 on the inside here. And if I'm going down 6, I will have a minus 6 on the outside of my function.